For the module on epidemiologic study designs, this is the lecture segment on cross-sectional study designs. So a cross-sectional study might also be termed a prevalence study. Key features of a cross-sectional study are that there are no formal procedure of random assignment, that selected subjects are persons in a given population at some point in time, and that exposure and outcome status are measured at the same time. So this third one is the key distinguishing feature of a cross-sectional study. Exposure and outcome status are measured at the same time. So that whole concept that we talked about, a population at risk, following them through time to find disease status, or cases and controls and looking at their past exposure, cross-sectional studies are not designed to be able to do that, and thus are seriously flawed for inference of cause and effect. So another way of thinking about it is disease status and exposure status. We can't see whether one is leading to the other or whether the causation goes in the reverse direction. If we're measuring both at the same time, we just know that both are present. We don't know which one caused which. So in a cross-sectional study, investigators ascertain present, that is to say prevalent disease status and exposure status simultaneously. The exposure studies may be very similar to those in randomized cohort or case control studies. The distinction of the study is not the type of data, it's the timing of when those statuses are measured. So taking our graphic of a study population followed through time, the cross-sectional study would be sort of the vertical dotted orange line, where we're going to only capture those individuals who are present in the study at the time the cross-sectional study is done. So the people who are from our theoretical source cohort who are already lost to follow-up are lost to our study, potential bias there. And then the disease status at the moment that the study was done. So if someone's disease status has changed over time, you're only capturing a snapshot of it. And if exposure status has changed over time, you're only capturing a snapshot of it. So again, usually the cross-sectional studies are actually carried out because the interest is in prevalence. We would like to know the prevalence of obesity in the US population. And so cross-sectional studies are carried out so that we can know this. We'd like to know what is the prevalence of cigarette smoking, whether smoking cessation and anti-smoking public health campaigns are succeeding. So they carry out cross-sectional studies to determine the prevalence of smoking and the prevalence of various diseases. So if the prevalence itself is of interest, a cross-sectional study is a very useful tool. But what inevitably happens is someone is like, oh, look at all this great data. Now I want to know whether A is associated with B, whether X is a cause of Y in this great data that someone has gone to the trouble of collecting. And so then they will try to do some kind of exposure and outcome association from cross-sectional data. And in fact, a lot of large cross-sectional data sets, you have lots of variables have been measured. So you may say, oh, well, this is my exposure of interest, this is my outcome of interest. Let's see if those are associated. And you can do those same calculations, but what you do not have is that confidence of a cause and effect of the time that the exposure was actually present before the outcome. So again, why would one use a cross-sectional design? They may be conducted relatively quickly or easily. In fact, in many cases, big cross-sectional studies have already been done, and the data are made available to, especially like a trainee, a graduate student, or a fellow. Oh, here's this great data set. You can do your paper. You can do a paper quickly out of here. The real reason for conducting a cross-sectional study, though, as I said before, is that a disease or exposure prevalence itself is what's of interest. So I'm giving examples of several really large national surveys that are done. The National Health and Nutrition Examination Survey, the National Health Interview Study, the Behavioral Risk Factor Surveillance System. All of these studies are very carefully designed to sample a random sample of the U.S. population or regional populations. They have carefully designed interviews to capture information about people's health behavior, about their health status. But the real purpose of these studies is the descriptive epidemiology, not cause and effect. Okay, so the problem with cross-sectional designs for causal questions is you don't know whether exposure preceded disease, and they may be prone to bias and confounding, especially bias of people who may have been lost from the theoretical population before the study was even done. So a selection bias issue. Okay, I just want to, that's really all I'm going to say about cross-sectional designs, except this last thing is that there's also this concept of cross-sectional measurements. So when we're talking about study designs, when we pull examples from the literature, we may find studies that have used a cross-sectional measurement, but that doesn't make the whole study a cross-sectional design. So if all the data, all the exposures, all the outcomes refer to one point in time, then I would call that a cross-sectional study. If a study actually follows people through time and they've collected a certain data set at one of those time points, I might call that a cross-sectional measurement, but it may not be an entirely cross-sectional study. So a cohort study that uses some cross-sectional measurements would not suffer from the same limitations of a cross-sectional study.